Okay, so I want to remake the tutorial I did on DrawIO. um, if you're seeing this video, it's because you're in one of my database classes, and sometimes you'll have to make ERDs, entity relationship diagrams. You could use whatever tool you want. If you can write really legibly, that also works, but this could be a little bit more convenient. And DrawIO is the one that I found the easiest to learn, to work with. Other possibilities would be stuff like Microsoft Visio and Lucid Chart and things like that. So in this one, I think the only thing you really need to have is a login for it. I believe I know you can do things to your Google Drive, like store your diagrams to your Google Drive. So I think, if I'm not mistaken, it has a Google sign-in if you want to use that. I don't know if it has other options. I'm in the Google ecosystem, so that's how I'm familiar with it. But aside from creating an account, it should be free. I know I haven't paid anything. So you get to this screen, create new diagram. This is all draw.io. This is a it's been redirected from there, but draw.io is the URL that will get you here. And this one is going to be stored on my device here. I might want to change the storage to, and this might be where you have different options, but if you do Google Drive and authorize it, I kind of figured mine was already authorized, but whatever. Yeah, I grant permission. Okay, allow, whatever. Yes, I'm confirming all that 5 times. Thanks. Okay, create new diagram, entity relationship diagram is what we want to create. Use root folder, yes. So you have to, regardless of how you do it, you have to tell it where to save the diagrams. So root folder would be the root folder of my Google Drive, which I'm not sure exactly where that is, but I'll find it later. The important thing is that you can start designing, right? Worst case scenario, just do a screen grab, which is Windows Shift S for anybody who doesn't know the best way to do it in Windows, in my opinion. Windows Shift S and draw a picture that you have in your clipboard. Draw a square around what you want. All right. So I recommend, this is a crow's foot model. I recommend using crow's foot. It's the easiest one to work with, in my opinion. It also has the capability of doing some chin diagram stuff. If you look down in this area where it says entity relation, you have your choices of different objects you can use to draw your diagrams. For like the simple diagrams that for the most part you'll have in class, crow's foot is perfectly fine. Chin's foot, there's no real, off the top of my head, I couldn't tell you any real benefit to doing chin over crow's foot. But if you wanted to do it, you can manage it. But I think it's a little bit more tedious because you have to put attributes around and connect them, each one, instead of just listing them inside of the crow's foot model. And it starts with this example diagram. So I don't know, I'm not going to look at this. What I'm going to do is talk about how, so I'm going to delete all these, in other words. Just highlighting and clicking the delete key. Let's see if it'll, there it'll do it. Let's start with our own example diagram. So let's start with the one I do very often. This is just a very simple one, which would be the doctors and patients. So that's a simple one-to-many kind of relationship. So the business rules would be, I want to write them out, but I'll just say them slowly because I don't know. There's probably like a text tool here somewhere, but I don't see it right off the top of my head. I'm on a hunt for it. The business rules that I want to model are: a doctor can have 0 or many patients, and each patient can have one and only one doctor. And they're not a patient if they don't have a doctor. So it's not 0 or more doctors. It's one and only one. It's not 0 or 1. It's 1 or 1. 1 and 1. Only one. I hope that's clear. So on one of the midterms when you write business rules, it asks you to use the word each rule. So if you do it that style, that would be each doctor has one or more 0 or more patients is what I'm going to do. It's going to be optional. So each doctor has 0 or more patients, and each patient has 1 doctor. All right. So you start by just getting the entities, and this is what they look like. Ignore like table. You don't really have to worry about these. They could be useful in other modeling contexts, and some of these things are Venn diagram. Again, this is associative entity. This is a relationship, strong and weak. I guess that you say this is stored in the cloud. There's all kinds of different other like more complex stuff, but the basic things you need are only the crow's foot stuff, which would be the entity boxes. So I would get out for this particular couple of business rules. You really only need 2 entity boxes. So you need one for the doctor entity, and the patient entity. Remember, it's all caps, singular by tradition, though you'll see a violation of that quite a bit, to be honest. And then I always kind of minimize the importance of the attributes when I'm talking about modeling things, but you would need, they're not unimportant when you model. I feel like they're easier to take care of once you identify them. You just list them inside the entity. The relationships are what usually get people kind of confused, so that's where I concentrate. But you do want to make sure you know what the fields that you need for your entities are going to be. These are your columns in your table, right? So did I type first name or first name? I don't have my monovision contact lens in, so I'm having trouble reading some of these. But last name, first name, that's all I'm going to put. There could be other ones depending on what's going on in the what's the word I want? In the clinic, the doctor's office. But we're going to go with these as a minimum. You need something that would serve as the primary key, right? So I'll call it patient ID and first name. Now, if you were doing like an enhanced ERD, you might have like a person entity, and these both could be, but they wouldn't intersect or whatever. So they would be disjoint. We're not going to get that complex. This is good enough for what I'm trying to model. So I'm going to go off on little tangents, at least a little bit, but we'll try to avoid it too much. Then you just model the relationship. So the relationship, the connectivity is from doctor to patient is 1 to many, and from patient to doctor is 1 and only 1. So the thing about these relationships is that you can do both sides of a relationship. You can do both business rules usually with one relationship when you're talking about how 2 entities are connected. And remember what I said is that the doctor can have 0 or more patients. He's still a doctor even if he doesn't have patients. But a patient's not going to be even like at that clinic unless they have a doctor. So this is the one we want. Looks like this. So it's going to have the little. It's not vary from the book. No, it doesn't. It doesn't vary from the book. Never mind. You'll see 2 lines on the one side, and you'll see a circle and a crow's foot on the other side. Then you just have to hook them up and find out where to grab them. There we go. And then text. There's the text that I needed before. Then you should technically label this. At least the active side. Ideally, you would do both sides. But let me see if I can figure out how to get this in here. I need a text box. Let me find that and get back to you. I mean, it's where it's supposed to be. This is just if you have text, what does it look like? Over here, it's going to be a component, right, in the general. So you got your general shapes and lines and stuff, and text is one of the general things, so it makes sense that it'd be there, actually. All right. So I'm going to say treats. You could say C's is assigned, whatever. And if you wanted to do the other side like you're technically sort of supposed to, probably that opinion varies on the. To me, I think it's fine to do one direction, but It should be active and passive. Passive is treated by, and you imagine the arrows going like this way and this way. So the treats part is going from doctor to patient, and then the is treated by is going from patient to doctor. So any particular patient, each patient is treated by one doctor, which is what that's showing there. So that's when you're going in that direction. When you're going in this direction, you see that each doctor treats 0 or more patients. Technically speaking, also, there should be a foreign key as an attribute, at least here. When you get to the table, when you're doing the modeling in crow's foot, because you list the attributes inside of here, you probably need to have that. But I want to say that figuring out where the keys go is sort of like a later step in this process. First, you identify the relationships, and then you're like, okay, this is the mini side, so it needs to have a foreign key. I know when it gets to the implementation into the database management system, that's going to have a foreign key. So, and if you think about it, if you like forget about the relationships between the two, you know that each patient needs to be assigned to a doctor. So I'm going to just call this assigned doctor. These can be called anything. Sometimes they'll just be called doctor ID, because it's sort of, when you have primary keys and foreign keys, they have the same name in both tables. So you know it's kind of easy to see at a glance how they relate. Typically that's the way it's done, honestly. It'll just have doctor ID in the patient table, and you know, well, that must be the doctor they're assigned, right? But you could alternatively call it assigned doctor. You just have to make sure that the value you put in that column is the actual primary key in the other table. But that's a simple demonstration of how you do like the typical one-to-many relationship. If the doctor had to have at least one patient in order to be considered a doctor, then you would put a bar here. There's like little tweaks you could make on this, but this is the typical one-to-many relationship. So I've got that one done. I want to make sure you see the other most common relationship. We're going to leave one-to-one on the side. That's, if you do one-to-one, you just find the one-to-one over here, right? I want to show many-to-many though. We got a phone call. I don't know who it is, but I'm making them leave a message. So I'm going to do movies and actors, my favorite. I don't think I've ever really shown it before, but this is an opportunity to actually demonstrate many-to-many and sort of show you what goes on with that. So we have two entities, movies and actors. They're going to have, the typical things, movie ID, actor ID, but it's a many-to-many relationship. So the business rules are this. Now that I know where the text goes, I'll put a box up here and like list them maybe. We'll see how this works. Put it down here maybe. So each movie, make this longer. Each movie, what's the word we want to use? The verb. Each movie, remember verb relationships are verbs usually. So each movie features one or more. These are the ones we're going to do anyway. These are the movies we're going to do. I mean, you can think of something like Koyaanisqatsi, Katsi, for example. It has people filmed in it, but they're not really actors, so I don't think it has any actors. So you could say 0 or more, but we're not going to do that here. We're gonna feature a many-to-many relationship, and then each actor performs. Let's use perform, so we don't just use act, because an actor acting is kind of like a little redundant. But anyway, each actor performs in, let's say 0 or more. 0 or more. Yeah, 0 or more. We could put 0 or more. Let's put 0 for we'll do Koyaanisqatsi as an opportunity. So those are the two main business rules I want to model. And you'll see, typically it'll be a pair between any two entities. There might be more business rules between two entities. There might be more than one relationship. You can have two. See how I have one relationship here? You could have two. There could be some other relationship, like, I don't know, patient pays one or more doctor, or whatever. That's not a good example, but that there are other opportunities for relationships besides the one between two entities. But typically, a couple of business rules that involve two identified entities is going to result, that pair is going to result in one relationship. So that's what we're doing here. I'm trying to think of any other business rules that would be involved here. Not off the top of my head. So it's not always the fact that you just have the two here. I can't think of a good example, counterexample of that, though. It's typical. Let's put it that way. It's typical that any pair of business rules is going to result in one relationship. So we'll have movie on this side. For whatever reason, I always put movie on the left, actor on the right, and then we're going to have movie ID, title. There's different styles here. I'm just going to stick with the simple word. Title, release year, and of course there could be all kinds of different, like the production company and the format of the movie. There's any number of things you can put here, but we're going to keep it simple. Actor ID. The other style would be movie title, movie release date. You putting movie in front of it as part of all the field names, so that when you see them in isolation, you know which table they belong to. And I'm not going to get that complex with it. We're just going to put the simple words in here. You know, for example, up here you have first name and last name. If you had doctor first name and patient first name, if you saw each of those fields in isolation for whatever reason, your field of vision zeroed in on that field, so to speak, and not any of the rest of the table or a schema or something, you would know that field if you saw it in isolation, like say in a piece of computer code that's interacting with a database or something. You would know that it was talking about that particular field in that particular table if it was called, for instance, patient first name instead of just first name. So it could be a good practice in real life, but in real life, where's this from? How did this get down here? I probably like hit enter and made them go down. Anyway, but for this example, I'm going to make it less complex. So we got movie ID, actor ID, and so to model this relationship, we need many to many. So it's 0 or more for both sides, which is kind of uninteresting. Actually, I should make it 1 or more again up there, just so it's a little bit more interesting. But uninteresting in the sense that both sides of this thing are going to be the same, right? It's going to be this one, many to many, and I think he had a label on it. Many, did it say many optional? Yeah. So it says many to many optional because it's optional on both sides. In other words, there could be movies that don't have actors, and there could be actors who never got hired for a movie, right? Never got past the audition. So, but they still consider themselves actors, even though they're serving tables in Los Angeles. You know, the cliche, right? Like. Everybody in Los Angeles, I don't want 2 of these, is an actor, even if they're not in movies. So I think so. One optional to many mandatory. You can see they named them here. So mandatory, again, that's the participation is what I call it. There are different terms for these. Cardinality, I always call connectivity cardinality and vice versa. Well, not vice versa, but I just use the word cardinality, but it turns out if you read the book carefully, cardinality is more of a case where you have the specific numbers involved, like 1 to 5 on one side and 5 to 10 on the other or whatever. But connectivity is just like how many things are on each side, how many doctors are involved with how many patients at a time. That's the connectivity. But whether or not a doctor has to be involved with the patient to be a doctor, that's participation. All right, so got these in here. This is what a many-to-many relationship looks like right here. So this is fine for the logical model. We'll say the higher up, the less specific model that's a visual model. You could, as an intermediary step before you get to implementation in the database, add to this model to make it easier to transition to the database management system. And the reason why, keep in mind, you can only do one-to-one or one-to-many relationships with primary keys and foreign keys and tables in relational databases. You can't directly do many-to-many. So in other words, this has to turn into two one-to-many relationships. So, and I've noticed when I ask you guys to list business rules, sometimes you do this. The example would be your hardware and software. The business rules, in my opinion, I'm not even sure if this is technically right. I would never think of it this way, but the business rules there are that, and again, I've said this before in the lab guide. I think I explained it this way, but I'm going to say it this way. Instead of software, I'm going to call it programs because it's easier to say it that way. Instead of hardware, I'm going to say machines. Just because those two nouns make the verbs easier when you say them, because you would have to say like an example, an instance of a hardware, a piece of hardware, and a piece of software, a particular software you'd have to like get more wordy. So when I say hardware, I mean, when I say machine, I mean hardware. When I say program, I mean software. So the business rules is that a program can be installed on 0 or more machines, and a machine can have 0 or more. It could be wiped clean, right? 0 or more programs installed on it. That's the business rules. But if you remember, because it's implemented in Access, which is a relational database management system, it has to observe that law of only having one-to-many relationships. You can't do directly many-to-many. So you have that configuration table. The only reason that exists is to make it possible to show that many-to-many relationship in the actual database. So you don't actually have to say business rules for it, in my opinion. In other words, you don't have to say that a program can be configured, have many configurations, and a machine can have many configurations. What does that mean? Like one machine has many configurations, and a configuration has one machine at most. A particular configuration, like it's not even, it doesn't make sense descriptively. Like, what do you mean configuration? You could say software, hardware configuration, like a combination. It's a combination really of the two, right? It's that those business rules in quotes only exist to make it possible for it to exist in a relational database management system. I don't know if that's clear to you, but what I'm saying is that for the access table, just think of it this way. For that access table, the access database, when I ask what the business rules are involving the software and the hardware, you don't have to include the configuration table because it's only there to make it possible to have those business rules about many programs on one machine, and one machine can have many programs on. Is that right? One program can be on many machines, and one machine can have many programs on it. That's all the business rules you need. You don't have to talk about the configuration table. So let me demonstrate this with this. What I'm going to do is just copy this. And again, what I'm about to do here is I'm going to model in an ERD that new table. And again, technically speaking, you could say those are business rules that are sort of describing what's going on when you add this new table. But again, I think it's not necessary to, like, in other words, this picture right here is a visual model in an entity relationship diagram of these two business rules. And the one that I'm about to show you is also a visual model of these two business rules. It's just an intermediary step to the implementation in the real database management system. So what I'm trying to say is you don't have to add to these rules to describe this next picture. This next picture is just kind of like a translation guide to how you would put it. I can't say this any more clearly, I don't think. So it's just like a helpers, training wheels for the database management system to get this thing right here, this picture, business rules and this included, like this whole idea right here, get this implemented in the database management system. I'm giving it like a little step up right here by showing this. So let me show it to you and stop talking about it. So I'm going to create a new entity. And the traditional name for these entities, this is an associative entity. If I were using Chin diagram, I'll show you what here in a second. This is crow's foot model. But if I were using a Chin diagram for my entity relationship diagram, the original thing, I would use this box. So I don't want to mix the models here, but the reason I would use this box though is because, and I've talked about this before, but it doesn't hurt to repeat it. See this diamond? Instead, in a crow's foot model, you have this stuff. But if it were a Chin diagram, you would have this diamond with lines from it. And the diamond's the relationship instead of just this line. And then the diamond would have the cardinalities on each side. Like in one, you know, it would have the 1 and the M and the 1 and the M, or 0 and M, or whatever. It would be a little different style, but it would be saying the same thing. But what I'm doing is I'm taking this relationship that's just a line in crow's foot, or it would be a diamond in Chin diagram, and I forgot to do this actually. Hold on. You can see I don't always do it, but so sometimes I'll leave this out because I feel like it's kind of implied. You can make up a verb, you can sort of understand, but it should be, you really should model it to be explicit about what's going on. So a movie, I'm just going to put features here, and then I'm going to put down here what I say performs. So this is one where you can have active both ways, just because of the way I did it. If you wanted to do the traditional style for naming these, you would say a movie features many actors, and an actor is featured in each actor is featured in many movies, right? So let's say is featured in. But you could also say an actor performs in many movies. So this bottom could have a different verb if you wanted, but I'll try to make the verbs the same. So this relationship would be features / is featured in. So that would be the relationship. And what we're doing is we're taking this relationship and we're turning it into an entity. And this should make sense when we're done, I hope. But the reason why this is called an associative entity is because it's an entity that associates two things, right? Brings them together. All right, so I'm going to put this down here to the side again. This is Chin diagram stuff. It's not crow's foot, so it should not be officially integrated into this interrelationship diagram because you're mixing your styles there. So movie actor is the traditional name for this associative entity. So again, it used to be features is featured in a relationship, but now I'm turning it into an entity. And again, the default name is movie_actor. All right. I wish I could show this better, but what you'll see is when you do this, it's that you insert it in between, usually physically. There's no reason it has to be between the two, but it makes more sense. And what you do, I'm trying to make this possible, like this, not confusing, but I think it's going to be confusing if I do it this way. But you're turning this one many-to-many relationship into two one-to-many. So what I tried to show is like you're shrinking it from this side, but if you take the same thing and shrink it this way, do that by duplicating it, maybe. Duplicate. So when you stick this in between the two, what happens is that it kind of shrinks. And you connect both of these, sort of like the two things are holding it up, right, in the middle. If you imagine these are hands, they're kind of holding it up now. And then you change this thing on both sides for these, the entities that were there to begin with. This participation turns into mandatory one, and it has to be mandatory one. It just makes sense after you start working with it, but mandatory one on both sides. And the reason is because you're not going to have either of these things here unless they're there, right? They're either there or they're not. So it's possible. This will make more sense when I show it, but let's get the one-to-manys out. So we go back to the original, this kind of relationship up here, actually. It's a one-to-many. And we said that it's optional, I believe, participation, right? So a movie might not have any actors in it, and an actor might not have any, might not be in any movies because they haven't been hired yet. So the way to show that is 2 optional, 1 to minis. So mandatory 1 to optional mini on both sides. So again, this one relationship turns into 2 of these. And I've already forgot where I got it from, so I'm going to have to hunt it again. There it is. So the one side goes to the original thing. Original entities. I got it. No, it's on the wrong side. But technically there's nothing wrong with that connection, but yeah, that looks better. So again, mandatory 1, mandatory 1. The reasons why it's mandatory is because neither one of these are going to be here at all unless they're there. I don't know how another way to say that, but they're either there or they're not. And I've said it that way already, but I hope that's not confusing. So what I'm trying to say is, for the movies that don't have actors, you'll go to the movie table and the actor, you'll have the movie there, but when you go to the configuration table, you won't have that movie in the configuration table. In between, I say configuration table. I'm sure I should say the associative entity or the bridge table, junction table is what this is called when you get to the database. So the configuration table and access that you have is a junction table or a bridge table. And you'll notice this if you look, if there are employees who do not have machines assigned to them, any employee who doesn't have a machine assigned to him will be he'll be in the employee table, but he will not be in the configuration table just because he doesn't have a machine assigned to him. Same thing here for movies. So if a movie doesn't have any actors, that movie, Koyanis Katsi, you look up, list all the movies in the movie table. Koyanis Katsi will be there. But when you go to the movie actor table, Koyanis Katsi will not have an appearance. The primary key will not be in there at all because there are no actors. But if there are any movies with actors, then they will appear in this table. And that allows you to do the 1 to many relationship with 0 participation. If this were not 0 participation or optional on both of these, then every movie would have to be in here somewhere and every actor would have to be in here somewhere. But that's not what's going on because it's optional. So this table may or may not have the actors and movies in it. Any particular one. But if an actor ever appears in a movie, that there will be an entry for that occurrence in here. I hope that's clear. Now what you'll see is I've got movie and actor, and that's because when you make this table in the database, you will normally, you don't have to necessarily, you'll have the foreign keys for sure. So there'll be a foreign key. There'll be a foreign key from this table. That's how you do a one to many relationship in a database management system. Is you have a foreign key from the one that is a primary key in the other. So this movie ID is a primary key of the movie table, but it's a foreign key here. So movie ID. This actor ID, I think I misspelled it too. A-C-T-O-R. I keep hitting too many. So this actor ID is a foreign key here, and it's a primary key here. So you got foreign keys from both sides. And usually they'll be combined together to make what's called a composite primary key. So you combine the 2 of these together for 1 record in this table. So 1 instance of an actor playing in a movie. We're leaving out stuff like what's his name? Mama's what? I'm trying to remember. Tyler Perry, right? We're leaving those out. That's more complex. You would have you'd have to like tweak this a bit to make that work because Tyler Perry or Medea, right? That's what I was trying to remember. That's more than 1 role for the actor in a particular movie. That'd be harder to model, but we're leaving out those cases. So anyway, you combine these 2 together, that makes 1 record. So my favorite example is with the Star Wars stuff. So if Star Wars is movie ID 1 and actor number 1 is Harrison Ford, then the table that has 1 for actor, the record in here that has 1 for actor, the row, 1 for actor and 1 for movie represents Han Solo. So, and here's what, let me add to this. I'm going to call this part. I just solved that problem. So it will be 1, 1 and Han Solo. He plays the part of Han Solo. And this allows us, because I didn't want to call it role in two places, is why. You could call this movie actor. That's the default name for a bridge table or junction table. Or you could make up an appropriate name. There you go. I think this, I like this example because I think that's very elegant how that works out. Now, keep in mind, parts here, why is part in this table is because, and this is later on, this is a preview of normal forms, because you have a composite primary key, and there's nothing, there should be no field in this table that doesn't depend on both of these at the same time. The entire primary key, in other words. So, you don't know that the value of part is Han Solo unless you know two things, the movie and the actor. If you know the movie, the part could be Harrison, it could be Luke Skywalker, it could be Leia Organa, it could be Jabba the Hutt. He was in the first one now because they stuck it in later on. It could be Greedo, it could be R2-D2. Kenny Baker's the name from the previous time that I forgot that. It could be C-3PO, it could be any of those if you just know Star Wars. If you just know actor, Harrison Ford, it could be Star Wars, it could be Raiders of the Lost Ark, 1, 2, 3, 4, 5 is about to come out. It could be Witness. It could be that one where he's got the young lover and she pulls him into the lake. I can't remember what that one's called. What else was he? What was it? A million. He's been in a million movies, right? So, but if you know both Star Wars and Harrison Ford, what do you know for sure? Han Solo. You have to know both of these at the same time. So part should never be over here, and part it doesn't even make sense at all for it to be over here in movie. But you might think actor, because he plays the part. No, it has to be here because you need to know both the movie and the actor to know the part. And there could be other things that you put here that depend on both of these things. But notice date of birth. You could have date of birth over here, right? Oh, Harrison Ford played the part of Han Solo and his birth was, but no, because the date of birth depends only on the actor ID, not the movie ID. He had the same date of birth regardless of which movie he was in. I hope this makes sense for the future, but anyway, this is enough to show you how you should model these things. So we've got the example, just a review here. We got an example of one-to-many. All these things were optional, but you can think of examples where you would have mandatory on this side. I'll leave that for you, but this is a one-to-many relationship. This is a many-to-many relationship, and this is an alternative way, a more on the journey to doing the implementation into the actual database management system version of this, because you will have to have something. You'll have to have this table regardless of whether you show it in the model. So this is just like a little stepping stone. Like, okay, I'll put the representation of the table I'm going to create here, and then you could say like an actor. I mean, if you want to talk about the business rules, you could add some for this. I guess this legitimate. What I'm saying is that both of these models serve for these two business rules, but you could like further describe the business rules this way and say that an actor has 0 or many or more roles, and a movie has 0 or more roles in it. All right. So it would be kind of a modification of those business rules to fit this in, but either way you do it. Again, what I'm saying is that every movie has 0 or more actors. This whole thing together kind of satisfies that business rule. But yeah, it's probably a matter of opinion whether you convert the wording of the business rules when you add this table or not. In my opinion, it's not strictly necessary, but it's also not wrong. If you have any questions about this tutorial, let me know. Oh yeah, well, one other thing. If you're going to show me if you want to ask me questions in like an email or something, I prefer that you export as like a ping is safe. Always pings are always safe. JPEG would work too. PDF, like most of these would work, but ping, just pick the first one, a ping. Portable network graphics, it should work on any computer pretty much. So export it as that first. And then you figure out where you save. You can just save it on your device if you want to, and then it'll be down here. And then like I can look at this more easily. Then if you send me like the DrawIO, if you save it somewhere, it'll be a DrawIO file, and that means I have to go to DrawIO to open it up. I don't want to have to do that, so I'm asking you to be nice to me. Now, where these save, I can never find them. When I come back to DrawIO, I think if you save them on the Google device, you can find them. there when you open. I don't know. I'm sure you can find it after you save it. But anyway, let's see, save, share, save, the exit, and then I do an existing one and look on my Google Drive. It's probably pretty obvious. And of course, I've got tons of stuff here, but somewhere in here should be the diagram. Looks like, here we go. Here's some diagrams. Let's see what this one is. I don't even remember doing this. This is not me. This is something I randomly saved or something, who knows. But anyway, you get the idea. Like, if you have any questions, let me know. And that should conclude this tutorial. And I didn't mean it to be 40 minutes, but that's okay.